In the previous lesson, we learned that an exponential function f of x equal a to the power x, where a is positive and not equal 1, is 1-to-1 on its domain. Therefore, as such, it has the inverse. The inverse of the exponential function a to the power x is called the logarithm to the base a and denoted as log with the subscript a. That is, f inverse of the function a to the power x is log to the base a of x. The notation is a bit intimidating, but you'll have to remember that we have a lot of exponential functions, and we want to have a notation that links an exponential function a to the power x with its inverse. For a function and its inverse, we have the following relationship. Y is f inverse of x if and only if x is equal f of y. So if my function f of x is a to the power x and the f inverse is log to the base a of x, we can rewrite this relationship as y equals log to the base a of x if and only if x is equal a to the power y. This relationship can be used to define the logarithm. Logarithm to the base a of x is such a number y that a raised to the y gives me x. So logarithm to the base a of x is an exponent to which the base a must be raised to obtain x. Using this relationship, we can compute the values of some logarithms. So let's look at the examples. The first logarithm is logarithm to the base 2 of 8. Now, to find the value of that logarithm, we have to think to what exponent should I raise the base 2 to get 8. And quickly we can answer that question that exponent is 3. And if I know the exponent to which I need to raise 2 to get 8, I know the logarithm. So logarithm to the base 2 of 8 is 3. Now next one is logarithm to the base 5 of 25. Again, I'm going to think to what exponent should I raise 5 to get 25. And again, answer comes quickly. This is 2. 5 to the second power is 25. So if I know that exponent, that I know logarithm. So logarithm to the base 5 of 25 is 2. The next one is logarithm to the base 4 of 2. So again, I'm thinking 4 to what power is going to give me 2. And remembering that the square root of 4 is equal to, and the square root of 4 is 4 to 1/2 power, then my answer is quickly that logarithm to the base 4 of 2 is 1/2. And the last example is logarithm to the base 1/3 of 9. So again, what I'm thinking is 1/3 to what power is going to give me 9. Now, if I can't see that immediately, I can think, okay, that question mark can be replaced by a variable. I don't know what it is, so I put it to the power x, and this needs to be 9, so I'm going to solve this equation. This is one of the equations that we discussed in the previous lesson, because one of the 3 can be rewritten as 3 to the negative first power. So we have the power of 3, and 9 is also power of 3. So this equation reduces to 3 to the negative x equals 3 to the second power, which implies that negative x is equal to, or x is equal negative 2. And therefore that my x that replaced question mark is my logarithm. This is logarithm to the base 1/3 of 9. This is negative 2. If I raise 1/3 to the negative 2 power, I will have the answer 9.